Then let's look at question 4, momentum. Now, the first thing that we look at is our target. How do we get 6 marks on momentum? We can get 6 marks by a definition. 2 marks definition. Which 2 marks can we look at? It's either the examiner can say define momentum, or define impulse, or state conservation of linear momentum, or define isolated system. Now they can even play with words and say elastic collision or inelastic collision. If they say what is meant by the term inelastic collision, you'll say collision in which kinetic energy is not conserved. So the reason for it becomes a definition. 2 marks. The following question, it is 3 marks or 4 marks. You look at the scenario. Initially, are they separated, these 2 objects, and they collide and separate? Or scenario number 2, initially they are separated, collide, then join together. Or scenario number 3, initially they were together, then collide and separate. If they ask you about the impulse, you must know the following question. You must use the formula F net multiplied by change in time is equal to change in momentum. So this is the information that we must know about momentum. So we are saying that as you perform calculations, read the scenario and understand which scenario is it applicable. Is it scenario number 1 or number 2 or number 3? And always remember to write the direction. When they say calculate the velocity, it must have both the magnitude and direction. Vectors, it must be both magnitude and direction. Calculate the net force, both magnitude and direction. Change in momentum, magnitude and direction. Refer to the data sheet and perform calculations. But these 3 scenarios, they are not there in the data sheet. So how do you get a mark for them? That is a question. You must first say the sum of momentum before is equal to the sum of momentum after. Then you read the scenario. If it's scenario number 1, then the formula that you can use, separate, collide, separate. It's M initial 1, M2, V initial 2, they collide and separate. M1 with the final velocity, M2 with its own final velocity. If it's scenario number 2, separate, collide, and join together. Then we are saying initially they were separated, M1 with the initial velocity 1, plus M2 with the initial velocity 2. They collide and join together, M1 plus M2, all with the same final velocity. If it is scenario number 3, initially they are together, M1 plus M2 with the same initial velocity. They collide and have their own final velocity, M1 with final velocity, M2 with its own final velocity. So familiarize yourself with these formulas because they're not there in the formula sheet. The exam guideline, it is telling us that we define momentum. You'll be able to define linear momentum, and you should be able to state Newton's second law in terms of momentum and be in a position to also define impulse. Not only that, calculate momentum, use Newton's second law to explain how does it help us with safety features, and perform calculations. Define impulse, be in a position to use the formula to calculate, and explain how does it apply to safety considerations on our everyday experience. Define the term isolated system, and then state the conservation of linear momentum. distinguish between elastic and inelastic collision by calculation. Now, I'm giving you 2 minutes to respond to this multiple choice question. Now, two bodies undergo inelastic collision. That's the clue. That's the key word. Inelastic collision. Look at the capitalized words. Inelastic collision. Remember, if we are saying inelastic collision, we are saying that the kinetic energy is not conserved. So already you must look for an option that will have a kinetic energy is not conserved. In absence of friction, which of the following combination about the system is correct? Already we know A and D, they are incorrect. So our answer is between B and C. Remember the conservation of linear momentum. It is telling us that the total linear momentum of an isolated system is conserved. So it means for momentum we are looking for conserved. For kinetic energy we are looking for is not conserved. And the correct answer is B. Then, here is an activity. I'm giving you 10 minutes to respond to it. Let's look at this question. A bullet of mass 20 grams, already it tells you that you must convert this mass, is fired from a stationary rifle. The rifle is stationary. Of mass 3 kg, assume that the bullet moves horizontal. Immediately after firing, the rifle recoils back with a velocity of 1.4 meters per second. So you look at the scenario, is scenario number 1 or 2 or 3? Initially, the bullet was in the rifle, so they were together. Then we fire, and then what will happen? The rifle will recoil back, and the bullet will move forward. So initially, we were together, we collide and separate. Calculate the speed at which the bullet leaves the rifle. So you can have two options here. The sum of momentum before is equal to the sum of momentum after. For just writing that, you get a mark. Initially, they were together. So you're going to say the mass of the bullet and the rifle, which is 3 plus 0.02. You must convert that 20 grams to kg. On a stationary rifle, which was 0. After firing, the rifle went back. So it went in an opposite direction. So that's why the final velocity is minus 1.4. We want the final velocity for the bullet. Then you solve, you get your answer as 210 meters per second. So 4 marks. 1 mark for the formula, substitution on the left-hand side, substitution on the right-hand side, and the answer. Then they are saying that the bullet strikes the stationary 5 kg wooden block fixed to a flat horizontal table. The bullet is brought to rest after traveling a distance of 0.4 meters into the block. Calculate the magnitude of the average force exerted by the block on the bullet. And your first challenge is you don't have the time here, because the formula that you're going to use is F net multiplied by change in time is equal to change in momentum. But your problem, you don't have time. So it means you must first get the time. And how do we get the time? Integration now. We must use VPM, equations of the motion, to get the time. So we must first get the time. If you use equations of the motion, change in x is equal to Vi plus Vf over 2 multiplied by change in time. Then you can get your time as 0.04 seconds. And then from there, you are able then to get your F net by saying The mass of the bullet is 0.02. Remember, it comes to a rest, which is 0 minus the initial as it hits the block, which is 210, divided by the time, which is 0.04. And your answer will be 1050 newtons. They wanted the magnitude. If they wanted also the direction, then you'll say in opposite direction. How does the magnitude of the force calculated compare to the force exerted by the bullet on the block? So here we apply Newton's third law. The force exerted by the bullet on the block is the same as the force exerted by the block on the bullet. So your answer will be remains the same. Then let's come to work, energy, and power. Question number 5. And we are saying ours is to set the target. So ours is to make sure that we set the target. And the learner is saying, okay, let me get 6 marks on work, energy, and power. This has been a topic that has been giving me sleepless nights. So now I want to make sure that I get a minimum of 6 marks. How do we get 6 marks here? We are saying that the first question is the definition, 2 marks. Which definition must I absorb? It's either they say conservation of mechanical energy, or they say work energy theorem, or they say non-conservative force, or they say power. So these are the 4 definitions that I must be comfortable with to give me 2 marks. The next question, it is going to be a free body diagram. If it's 3 marks, I'm having 2 plus 3, which is 5. After free body diagram, then they'll start with their calculations. You look at the mark allocation. Pay specific attention on the mark allocation. If they said state work energy theorem, the first calculation, you must use work energy theorem. If they are saying state the conservation of mechanical energy, the first calculation, you must use the conservation of mechanical energy. That's number 1. The next calculation, it will be 5 marks. Once the mark allocation says 5, 6, 7, then it means you must use the energy principles. Even if you don't know what the question requires you to do, they can say calculate the efficiency rate. And you don't know efficiency, what is that? But if you use the energy principle, already you're having 2 to 3 marks. So when you see 5 marks, 6 marks, or 7 marks, you just say work net is equal to change in kinetic energy. Or you use the work done by non-conservative force is equal to the sum of change in kinetic energy and potential energy. So this is the information that all of us must have. So these are the energy principles. Work energy theorem, you can also define it by looking at the formula sheet. The work done by non-conservative force. So when you see the 5 marks, 6 marks, 7 marks, you choose one of the 2 formulas. Read and understand the statement. We cannot overemphasize that. You must be in a position to take out your data from the statement. Then, which definition? Work. They can ask it now. They did it in November 2024. Define the term work done. Then, work energy theorem. We must also know it. Must also know conservative force and non-conservative force. We must know power. We must know the principle of conservation of mechanical energy and be in a position to use it to perform calculations. Then here is a multiple choice question. Now, I am interested in your response. A car moves up a hill at constant speed. That's what is happening. Which one of the following represents the work done by the weight of the car as it moves up the speed? So, the work done here, it is the work done by gravitational potential energy. So, A and C cannot be correct. But now, as this car goes up, you can see that the work done by the weight, it is working downwards. So the most correct answer is going to be D. It is the change in potential energy. Then, I'm giving you 10 minutes to respond to this question. Now, let's provide feedback to this question. A 20 kg block is released from rest from the top of the ramp at point A at a construction site. The ramp is inclined at an angle of 30 degrees to the horizontal, and its top is at a height of 5 meters above the ground. The first question states the principle of conservation of mechanical energy. So for you to get 2 marks, define it the way it appears from the exam guideline. The total mechanical energy in an isolated system is conserved. We no longer use the word closed. So if you put closed, you'll be marked wrong because it is on an isolated system, not closed. 5.2. The kinetic frictional force between 20 kg and the surface is 30 newtons. Use the energy principles to calculate the work done by the kinetic friction. So there, you can have the work done by the kinetic friction by saying the work done by kinetic friction is equal to frictional force multiplied by displacement cos theta. Because we were not given the displacement, we can get the displacement by using trig ratios. So this is our opposite side and this is our longest side. Then it becomes sine theta is equal to y over r. And what is our opposite side? It is 5. And what is our longest side? It is r. So we can say r sine 30 is equal to 5. And then we solve for r. R becomes our displacement. Then you will have 30 multiplied by 10 cos 180. And then our answer will be minus 300 joules. Remember, frictional force, it does negative work. So all the time when you see frictional force, it's cos 180. Then the next question, calculate the speed at B. Because you are seeing 5 marks there, I did say you'll have 2 options. It's either you use the work done by non-conservative force or you use work energy theorem. I prefer work energy theorem because you'll have to draw a free body diagram, which is work net is equal to change in kinetic energy. The work done by gravitational force plus the work done by frictional force is equal to 1 over 2 mvf squared minus 1 over 2 mvi squared. The work done by gravitational force plus minus the work done by frictional force is minus 300 is equal to 1 over 2. Our mass is 20. And we want the final velocity squared minus initial, because initially at the top it was at rest. So the initial velocity is 0. And then the work done by gravitational force is 20 multiplied by 9,8 sine 30 with a displacement of 5 over 0,5 cos 0 minus 300 is equal to 10 VF squared. Then we solve for the VF squared. we are going to get our final velocity, which is 8.25 meters per second. Then, the next question, a 100 kg object is pulled up by the same ramp at the constant speed of 2 meters per second by a small motor. The kinetic frictional force between 100 kg object and the surface of the ramp is 25 newtons. Calculate the average power by the motor. So the power there, we can say power. Before we get power, we can get the constant force, which is the work done parallel by gravity plus frictional force. Then it's going to be 100 multiplied by 9.8 sine 30 plus frictional force, which is 25, is equal to 515. So power average will be the force multiplied by constant velocity, which is 515 multiplied by 2, and then our answer will be 1030 watts. Doppler effect on question 6. This one we are saying operation teka hinkwaswo. We are saying here let's get total. We are saying here let's get all the marks. How do we get the marks? The first question is the definition. Sometimes they don't say the definition. They say which phenomenon. When you see the word phenomenon in question 6, your answer must be Doppler effect. When they say define, you define Doppler effect. The formula for Doppler effect is the frequency of the listener is equals to V plus minus VL over V plus minus VS, all multiplied by Fs. So let's write this formula as original as it is, and be in a position to know that if the source is moving, the listener is stationary. If the listener is moving, the source is stationary. And if the source is moving towards, then Vs is negative. If the source is moving away, then Vs becomes positive. If it's the listener that is moving, if the listener is moving towards, then VL is positive. If the listener is moving away, then the VL is negative. Interpret graphs and note the application of Doppler effect to measure the rate of blood flow, to measure the rate of heartbeat in a fetus. So, our calculations, they're influenced by that. Let's know the definition of Doppler effect, perform the calculation of Doppler effect, state the application of Doppler effect, explain redshift. So in the exam, if they ask you, is this blue shift or redshift? Your answer will be clear. It is going to be redshift. And you must explain redshift. The distant stars are moving away. Longer wavelength, lower frequency at the end spectrum. What does this mean? It means that the universe is expanding. Let's deal with this question in 2 minutes. Which one of the following is the main principle applied when measuring the rate of blood flow or when measuring the heartbeat of a fetus in the womb? And we know which topic are we dealing with here. It is Doppler effect. So the correct answer will be A. Then I'm giving you 13 minutes to attempt this question. An ambulance is moving towards a stationary listener at a constant speed of 30 meters per second. The siren of the ambulance emits a wave having a wavelength of 0.28 meters. Take the speed of the sound in the air as 340 meters per second. The first question, state Doppler effect in words. So we define Doppler effect the way it appears from the exam guideline for us to get 2 marks. 6.1.2, calculate the frequency of the sound emitted by the siren as heard by the ambulance driver. Remember here we're given the wavelength. So then you are going to say V, which is the speed, is equals to frequency multiplied by lambda. What is the speed of the sound in the air? 340. We want the frequency. We know our wavelength is 0.28. Then you solve for frequency. You are going to get the frequency of the source as 1214.29 Hertz. Then calculate the frequency of the sound wave emitted by the siren as heard by the listener. So here the question wants us to determine the frequency of the listener. Remember here already we have the frequency of the source. So what is the frequency of the listener? You must write the correct formula. That's number 1. Write the formula as original as it is. Then from there, we are saying that the source is moving towards. So if the source is moving towards, Vs will be negative. So what will be the frequency of the listener? Is equals to 340, which is the speed of the sound in the air, divided by 340 minus 30, multiplied by the frequency of the source, which is 1214.29. So you can see here, from writing the correct formula and substituting correctly, you are having 80% of the mark allocation, 4 out of 5. So 1 mark for the correct formula, 1 mark for 340 on top, 1 mark for minus 30, and 1 mark for frequency of the source. Then you solve, you answer, the frequency of the listener will be 1331.80 Hertz. Then, how would the answer calculated in 6.1.3 change if the speed of the ambulance was less than 30? You can even make that calculation, put 28 there. If you put 28, you can see our answer will be less than 1,300. So it means what will happen? It will decrease. Then, an observation of the spectrum of a distant star shows that it is moving away from Earth. Explain in terms of frequency how it is possible to conclude that the stars are moving away from the Earth. So you must first tell us about the frequency, that we're going to have lower frequency at the end spectrum. Why? Because the spectral lines are redshifted. So when they say in terms of frequency, be specific. In terms of wavelength, be specific. The spectral lines will be redshifted. And what will happen to frequency? Lower frequency at the end spectrum. So with Doppler effect, let's make sure that we get total. Let's go to question number 7. Electrostatics. And then here we are saying that from grade 10, the principle of the quantization of charge and also the phenomenon of polarization, where as well we can have a new charge. Charge 1 and charge 2, they are brought closer together, they're in contact, and they separate. Once they've separated, we'll have a new charge. Because we'll use the formula Q nu is equals to Q1 plus Q2 over 2, and this will give us a new charge. Grade 11, you did Coulomb's law, net electrostatic force, electric field at a point. And this is the formula sheet. So we need to familiarize ourselves with the formula sheet. Let's make sure that we perform calculations and make reference of the formula sheet. Now, here is our weapon to get marks on electrostatics. We are saying that number one, we must know the expected definitions. The examiner can say state Coulomb's law. So we must state Coulomb's law according to the exam guideline. Or define electric field. Or electric field at a point. So these are the three definitions that we need to make sure that we know them. Coulomb's law, electric field, and electric field at the point. We should be able to use or solve problems using the formula of Coulomb's law. F is equals to K Q1 Q2 over R squared. And also be in a position to draw the electric field lines for the single point charge or for two charged spheres. Can be positive positive or positive negative or negative negative. Perform calculations using the formula. Electric field is equals to electrostatic force divided by charge. Or electric field is equals to KQ over R squared. And they are saying the examiner must be restricted to 3 charges. So question 7 will have a maximum of 3 charges, not more than that. Let's look at this multiple choice question in 2 minutes. The diagram below shows the electric field pattern due to 2 points X and Y. X and Y. So you know that for positive, the electric field lines, they go out. Negative, in. Positive, out. Negative, in. So when you look at X, they are going out. So it means X is positive and Y is negative. And which option is that? It is C. Then, I'm giving you 10 minutes to respond to this question. Question 7. Sphere 1, Q1, with a charge of negative 2,5 times 10 to the power negative 6 Coulomb is placed 1 meter away from second sphere Q2 with a charge of plus 6 times 10 to the power negative 6 Coulomb. So how do you know that is negative 6, negative 9? So you must know if you see UC times 10 to the power negative 6, NC times 10 to the power negative 9, PC times 10 to the power negative 12. And then it continues to Fermento and others. The distance of 0,3 meters to the left of sphere 1. While point X here at this charge, it is positive, is located between Q1 and Q2. Show with the aid of a vector diagram why the net electric field at X cannot be 0. So if you draw your vector diagram, you would be able to see that if X goes to charge 1, it gets attracted, which is Q1. If X goes to Q2, it is repelled in that direction. So this one is Q2, this one is Q1. So it is because the electric field of Q1 and electric field of Q2 will move in the same direction. So for doing the vector diagram, 2 marks. For providing the reason, 2 marks. Calculate the net electric field at point P. So also you must have a direction. So a child can say, let left be positive, because already you can see both of them, they are moving to the left. And then you can start with Q1. E1 is equal to KQ over R squared. Our K is a constant, 9 times 10 to the power 9. Our charge is 2,5 times 10 to the power negative 6 over the distance from X to Q1, which is 0,3. Don't forget to do what? To square. And then we come to Q2. Electric field electric field for charge number 2 is equal to KQ over R squared. Our K is 9 times 10 to the power 9. Our Q is 6,6. Okay. For charge 2 is KQ over R squared. Let's substitute. 9 times 9. For charge 2, electric field, KQ over R squared. We substitute. K is a constant, 9 times 10 to the power 9. Charge 2, 6 times 10 to the power negative 6, divided by the distance from charge 2 to X, which is 1,3. Don't forget to do what? To square. And then our E net will be E for charge 1 plus E for charge 2, which is 31,952,66 plus 250,000. Then our answer will be 281,952,66 newtons per coulomb to the left. So direction, direction, direction. Let's go to electric circuits. Electric circuits, you must know this definition: the EMF, the Ohm's law, or the power. One of these definitions will come out to get 2 marks. And then from there, you must know how the circuit diagram is established. Are we having a series circuit? Are we having a parallel circuit? Are we having series parallel? Or are we having parallel parallel? Then we look at the exam guideline. It states Ohm's law, and you must know the relationship between the current, the potential difference, and the resistance. Be in a position to perform calculations using R is equals to V over I. Then you must define power as the rate at which work is done. You can use the formula for power, work divided by change in time, or power is equals to VI, or power I squared R, or power V squared over R. And the units for power, it's watts. Also, the cost of electricity, you can be required to perform a calculation. Solve problems. I always say here, in grade 12, the circuit diagram, if you are given the EMF, you will be required to calculate the internal resistance. If you have the internal resistance, you will be required to get the EMF. If you have both internal resistance and the EMF, you will be required to calculate the total current. So you should be in a position to use one of these formula. The circuit diagram provided will be limited to 4 resistors. So, information that is important, it is about these 3 concepts: current, potential difference, and resistance. So, we are saying that in series, the current is the same. The potential difference is divided. And then in parallel, it is the opposite. In parallel, the current is divided. The potential difference across resistors connected in parallel is the same. I'm giving you 2 minutes to respond to this question. The 4 resistors P, Q, R, and T in the circuit are identical, but we look at how are they connected. The cell has an EMF and the switch is initially closed. Now the switch is opened. Which one of the following combinations will change? Or the changes will be observed in PRT. PRT. Now that the switch is open. So, if the switch is open, we know that the resistance, it will increase. If the resistance increases, what will happen to the current? The current will decrease. So we must look for the option that is the current that is decreasing. So our answer is between A and D. A and D. Now, if you look at the current at R, it says that here the current will remain the same. At D, we are saying that the current will increase. Remember before it was in parallel. So now because switch S is open, it is in series, the current will increase. So we're looking for the option that says in P, the current will decrease and the current in R will increase. So our obvious answer is going to be D. Then, let's look at this question. I'm giving you 11 minutes to respond to it. A learner connects a high resistance voltmeter across a battery. The voltmeter reads 6 volts. So this is the terminal potential difference. She then connects a 6 ohm resistor across and the voltmeter now reads 5 volts. Calculate the internal resistance of the battery. So now you know that we can use V is equal to IR for V lost, or we can use the whole formula EMF is equal to total current multiplied by R external plus internal resistance. Our EMF is 6 is equals to our total current. You must get it first. V is equals to IR. So if our V is 5 and our R is 6, our current will be 0.83. You get 2 marks for that. The other 2 marks will be to substitute the total current, which is 0.83. Our R external is 6. We want the internal resistance. Then you solve for small r and your answer will be 1.23 ohms. Then the learner now builds a circuit alongside using the same 6 volt battery and 6 ohm resistor. She connects an unknown resistor X with the 6 ohm resistor. The voltmeter then reads 4.5 volts. Define the term EMF. 2 marks. You must define EMF the way it appears from the exam guideline, which is the maximum energy provided by the battery per unit charge passing through it. Calculate the resistance X when the voltmeter reads 4.5 volts. So, you can get the total current there and say we use V lost is equals to IR. We know our V lost is 1.5. We know our internal resistance is 1.2. So we divide both sides by 1.2. We could get the total current, which is 1.25 amperes. Then once we have the total current, which is 1.25 amperes, we can get the V parallel, the potential difference parallel to the 6 ohm resistor. We are told that now it reads 4.5 volts. We can get the current that passes through the 6 ohm resistor. So we solve for the current, we divide both sides by 6. the current that passes through the 6 ohm resistor is 0.75 amperes. Then for us to get V and X, we know that now the V terminal is 4.5. It will be equal to the current, which is the total current, which is 1.25, minus the current that flows on the 6 ohm resistor, which is 0.75. Then we solve for R, we divide both sides, then our R and X will be 9 ohms. Then we move to electrodynamics. It is the extension of electric circuits. It's just that now we are bringing it to the machines. And there are two machines that will be assessed on. It's either the examiner will speak about the generator or the examiner will speak about the motor. A generator or a motor. So it is important to always include the subscript RMS. IRMS is equals to Imax over root 2. VRMS is equals to Vmax over root 2. Power average, if this average is not there, you lose all the marks, is equals to VRMS multiplied by IRMS. Power average is equals to I squared RMS multiplied by R. Power average is equals to V squared RMS over R. Make sure that you write the subscripts. The exam guideline, it says you must know how to state the energy conversion. You know from the generator is from mechanical energy to electrical energy. It means for the motor, it is the opposite. Use the principle of electromagnetic induction to explain how a generator works. You must know which component makes an AC. It's a slip ring. Which component makes DC? It is a commutator. Explain the energy conversion of motor. Use motor effect to explain how the motor works and the uses of motor. The advantages of AC over DC. Draw the graph of AC. Draw the graph of DC. Then it says you must define VRMS, which is RMS potential difference, as an AC potential difference which dissipates the same amount of energy as an equivalent DC potential difference. Define RMS current as an alternating current which dissipates the same amount of energy as an equivalent direct current, and use the formulas that we have spoken about to solve problems. What is important here? Write the subscript RMS, 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 average, average. I'm giving you 2 minutes to respond to this. A simplified diagram of an electric motor is shown. When the switch is closed, coil ABCD rotates. So we want to know, how is this coil rotating? You look at the direction of the current. Conventional current will move from positive to negative. So it means the coil will also rotate clockwise. So the answer would be A. Then I'm giving you 9 minutes to respond to this. The graph below shows the output voltage of a household AC. You can see the graph. It speaks to AC. For one complete cycle, a 100-watt light bulb is connected to this generator and it glows at its maximum brightness. Use the information from the graph to calculate the following. The resistance of the light bulb. If you look at the information that we're given the power and we're having Vmax. Once you have Vmax, you can use the formula VRMS is equals to Vmax over root 2, which is option number 2. Our Vmax from the graph is 340 over root 2. Then we're going to get 240.04 volts. That is our VRMS. Once you have the VRMS and the power, you can choose the formula power average is equal to V squared RMS over R. What is our power? 100 is equals to V squared RMS 240.04 squared over R. You solve for R and you're going to get 578 ohms. The second question, calculate RMS current. You can say power average is equals to IRMS multiplied by VRMS. What is our power? 100. We know our VRMS is 240.04 multiplied by IRMS. Then you divide both sides by 240.04. You are going to get 0.417 amperes or 0.42 amperes. Give one reason why AC voltage is preferred. It is cheaper and easier to convert AC to DC. Or another learner can say AC voltage can be stepped up or down using transformers. Then let's go to the last question. Photoelectric effect. We are saying here again, you must be in a position to use the formula E is equals to work function plus EK max. And the definitions that you can find there is photoelectric effect, it is work function, it is threshold frequency. These three, you must know one of the definitions, you'll be expected to respond to it. When you perform calculations, refer to the data sheet. Refer to the data sheet. So read the scenario carefully before answering. Refer to the data sheet and the subscripts. Subscriptive 0, threshold frequency F subscriptive 0. You must always make sure that you indicate them. Interpretation of graphs, and also you'll be asked which one is an independent variable, which one is a dependent variable. So when you look at the exam guideline, it defines photoelectric effect, it defines threshold frequency, it defines work function. It says perform calculations using this formula where energy is equal to HF and work function is equal to H multiplied by threshold frequency. EK max is equal to 1 over 2 mV squared. Explain the effects of intensity and frequency on the photoelectric effect. State the significance of photoelectric effect, and the answer is it demonstrates the particle nature of light. Then emission and absorption spectra. The formation of atomic spectrum, we can have what you call emission spectrum and absorption spectrum. Absorption spectrum, we are saying that the atom, it moves from a lower energy level to a higher energy level and absorb energy. If it is emission spectrum, the atom moves from a higher energy level to a lower energy level and release photon. And another obvious clue is that if you see the word cold gas, it's absorption spectrum. If you see the word hot gas, it is emission spectrum. Then, I want us to look at this question. Which one of the following phenomena provides the most conclusive evidence about the wave nature of light? And the phenomenon that we're talking about, it is photoelectric effect. So, in question 10, when you see the word phenomena, you must know your answer is photoelectric effect. Then, I want us to look at this activity. Right? A learner must look at this activity. A teacher in a science class explain how different types of spectrums are obtained. Already you look at the obvious clues. If they are saying hot gas, it's emission. If they're saying cold gas, it's absorption. So Y is emission spectrum, and then Z is absorption spectrum. So they are saying name the type of spectrum. You see, we've given the answer. Y will be emission and Z will be absorption. 10.2. In an excited atom, electrons can jump from lower energy level to higher energy level, and they can drop from higher energy level to lower energy level. So the diagram shows some of the transition of electron in an excited atom. When you look at this diagram, does it indicate absorption or emission spectrum? It indicates emission spectrum. Why emission? Because the atom moves from a higher energy level to a lower energy level. Calculate the frequency of the photon produced when electron in an excited atom makes a transition from energy level 4 to energy level 2. So you are going to say that the energy released is equals to energy 4 minus energy 2. The energy from 4 is 2,044 times 10 to the power negative 18 minus the energy level 2, which is 1,635 times 10 to the power negative 18. And then our answer will be 4,09 times 10 to the power negative 19 joules. Then from there we can get the frequency and say energy is equals to H multiplied by frequency. Our energy now we know is 4,09 times 10 to the power negative 19 is equals to the Planck's constant, which is 6,63 times 10 to the power negative 34 multiplied by frequency. We divide both sides by the Planck's constant. Our frequency will be 6,17 times 10 to the power 14 hertz. So that's how we get that 4 marks. The next question, it is saying the threshold frequency of a metal Q is 4,4 times 10 to the power 14 hertz. So let's fix it. 4,4 times 10 to the power 14 hertz. Calculate the kinetic energy of the most energy electron ejected when photon produced in 10.2.2 is incident on the surface of the metal Q. So here we're using the very same energy, which is 4,09 times 10 to the power negative 19 joules. So you must write the formula. Energy is equals to work function plus EK max. Our energy is 4,09 times 10 to the power negative 19 is equals to our work function, which is H multiplied by threshold frequency, which is 6,63 times 10 to the power negative 34 multiplied by the given threshold frequency, which is 4,4 times 10 to the power 14 plus EK max. Then you transpose the work function. If you transpose it, you're going to get energy minus work function is equal to EK max. And our answer will be 1,17 times 10 to the power negative 19 joules. Then, the next question is saying, another metal R has a threshold frequency of 7,5. Let's write it, 7,5 times 10 to the power 14 hertz. Will the photon produced be able to eject electrons from the surface of metal R? Yes or no? And give a reason for your answer. The answer would be no. Why? Because the threshold frequency is greater than the frequency of the photon. When we look at the summary, we are saying that more than anything, let's make sure that we have our exam guideline as we prepare for our exams. And physics, we can pass it only if we write the correct formula from the data sheet. We substitute correctly from the original formula. Our answer must have units and direction. Let's make sure that we deal with facade. Facade should be our middle name. And your final answer is the one that you must round off. And also, let's make sure that as we draw the free body diagram, your dot is big enough. Don't make superimposed forces, and your arrows, they must touch each other. All definitions, they must come from the exam guideline. All definitions must come from the exam guideline of 2021. The formulas, we are saying that make sure that if a formula has a subscript, indicate the subscript. Because wrong formula, wrong everything. Electric field lines, make sure that they are perpendicular to each other and they don't touch each other. Electrodynamics, if you know what is happening on the generator, you will know what is happening on the motor. If you know the component for AC is a slip ring, then you'll know that for DC it's a split ring or a commutator. So with all of this, we are saying that let's adequately prepare ourselves for this exam. It is in you, learners, to create a future better world for all of us to live in. I wish you well for your upcoming exams. Thank you. See you next time.